In this binomial, next question, prove that C0 plus C1 x by 2 plus C2 x square by 3 plus so on plus Cn x to power of n by n plus 1 is equals to 1 plus x whole to power of n plus 1 minus 1 by n plus 1 into x. So consider here LHS as it is. Next, C0 means NC0, C1 means NC1, C2 means NC2 and so on NCN and as it is x terms. So here in the RHS I need n plus 1 x in the denominator na, so that I am multiplying divided with the denominator term. So n plus 1 into x by n plus 1 into x and the one is as it is down. So I want denominator, I am continuing denominator, just multiplying with numerator. So n plus 1 nc0 and 1x, n plus 1 nc1 and x into x square by 2 plus so on, and the last one also n plus 1 ncn and this x into x to power of n by n plus 1. Now we have a formula n plus 1 nc0 and here what there x by 1 there na, so this 1 will be attached to 0 place, n plus 1 will be come to the n's place, that is a formula. So here it will be n plus 1 c1 into x. The same thing, this 1 is occupied by 2 and this n is occupied by n plus 1 by using the formula. So this will becomes n plus 1 c2 and extra x square and so on, and n is occupied by this n plus 1, this n is occupied by this n plus 1. So n plus 1 c n plus 1, only left over x into x to power of n. Bases are same, power should be added. So x power n plus 1. So now it is series started with c1 but it should be started with c0 na. So missing term adding in the beginning and subtracting in the end. So n plus 1 c0 adding and this one as it is continuation, last term and minus n plus 1 c0. From here to here it is looking like binomial expansion 1 plus x whole to power of, generally n will take, but instead of n here n plus 1 is there. So 1 plus x whole to power of n plus 1 and any c0 value is 1. So minus 1. So this is only our RHS, hence proved. Show that C0 CR plus C1 CR plus 1, C2 CR plus 2 and so on Cn minus R Cn is equals to 2n Cn plus R, and also 2 bits also there. So here very important problem, very confusion problem. 1 plus x whole to power of n, formula expansion C0 C1 into second term x, C2 into second term is increased and so on CR, 2 means power 2 na, so R means power R, so CR x to power of R and so on, last term Cn x to power of n we should write. Next, just I am interchanging the letters. So first x plus 1 whole to power of n is equals to C0. Start with this starting term. So what is starting term here? X. So x power n. C1 x to power of n minus 1 because first term decreases by 1 time. So second term increases. Second term means 1 power anything 1. So no need to write. But first term we should write. So x is decreased to 1 time. X power n minus 1. Next C2 x to power of n minus 2. 1 means n minus 1. 2 means n minus 2. And so on. CR. CR means x to power of n minus r. Plus so on Cn. Last term will be in the first term eliminated. Only Cn left over. So product of these two. Why? Because in our question given product wise na, that's why 1 plus x whole to power of n, x plus 1 whole to power of n. So this into this one. That's all. So here you see bases are same, power should be added. So a 1 plus x whole to power of n plus n is 2n. And this product into this product as it is I am not writing. I am not just elaborating. Here LHS, the coefficient of x to power of n plus r is 2nc n plus r. In the RHS, the coefficient of x to power of n plus r is C0 with here CR. That's why C0 CR. Next C1 CR plus 1. C2 CR plus 2 plus so on Cn minus R Cn. So if you get confusion, you just see the question. In this question what there LHS, that you write. Enough. Therefore coefficients are equal now. So that C0 CR plus C1 CR plus 1 plus so on Cn minus R Cn is equals to 2n Cn plus R. Then we have to prove that here 2 bits. For the first bit I am taking R value is equals to 0. What will be here formula? C0 CR C0 C1 C0 plus 1 is 1 C2 C2 plus so on Cn Cn is equals to 2n C n plus 0 means n only. So C0 square C1 square C2 square and so on Cn square is equals to 2n Cn. Hence proved of first bit. Now second bit. Let R is equals to 1. So what will be the star equation? C0 CR means C1. C1 CR plus 1 means 1 plus 1 na 1 plus 1 2. Next C2 C 1 plus 2 and so on Cn minus 1 Cn is equals to 2n C n plus R na, so n plus 1. So C0 C1 C1 C2 C2 C3 and so on is equals to 2n C n plus 1, hence proved. Next, if the coefficient of 4 consecutive terms in the expansion 1 plus x whole to the power of n are a1, a2, a3, a4 respectively, then show that a1 by a1 plus a2 plus a3 by a3 plus a4 is equals to 2a2 by a2 plus a3. So in the expansion 1 plus x whole to the power of n, the general term tr plus 1 is equals to ncr, first term power n minus r, second term power r. So first term is 1, second term is x. So 1 power anything 1 only, so it becomes ncr only x to the power of r. So x power r coefficient is what? ncr. So here what he told, let us assume the coefficient of 4 consecutive terms are a1, a2, a3, a4. So I am taking nc1, nc2, nc3, nc4 respectively. So here LHS is equals to a1 by a1 plus a2, a2 by a3 plus a4. So substituting the a1 value, a2, a1 and a3, a3, a4. And you observe here numerator nc1, denominator nc1 is there now. So taking nc1 in the denominator common. The same thing here also, taking nc3 in the denominator common. What will be? Numerator as it is, denominator taken. From the first it is taken 1, but from the second it is not there now. So we should write nc2 by nc1 plus. Here also numerator as it is, denominator taken common. Outside came it is 1 plus, in this not there now. So denominator should come nc4 by nc3. So 1 by 1 plus. Here one formula is there. What is that? NCR by NCR minus 1 means NN should be same. R preceding number R minus 1. The formula is N minus denominator will comes to numerator. Numerator will comes to denominator. So the application here, N minus denominator 1 will goes to numerator, 2 will come to denominator. Here also 1 plus NN same, 4 preceding 3. So denominator goes numerator, numerator will comes down. So n minus 3 by 4. LCM of the denominator. So 1 and 2 is 2. 2 ones are 2. N minus 1. 1 and 4 LCM is 4. 4 ones are 4. N minus 3. So here 2 minus 1 how much? 1. 4 minus 3 also 1. So again LCM of denominator n plus 1 as it is. So only numerator addition 2 plus 4 is equals to 6. Keep aside equation 1. Next we have to show that RHS now. RHS what is given? 2 A2 by A2 plus A3. So here directly I am taking common of denominator. Taking A2 common. A2 gets cancelled. Only what left out? 2 by 1 plus A3 by A2. So 2 by 1 plus A3 means NC3. A2 means NC2. Same N and same. 3 preceding 2. So we can apply the formula. N minus. Denominator goes to numerator minus 2. Numerator will comes to denominator. So LCM of denominator 3 ones are 3. So here 2 by 3 plus n minus 2 by 3. Denominator will goes to its numerator. So 3 2s are 6 it will be. So 3 minus 2 is 1. So 6 by n plus 1 equation 2. So equation 1 and 2 both are equal, no? So that hence proved. Next, very important and lengthy but easy. If second, third, fourth terms in the a plus x whole to power of n are respectively 240, 720, 1080, then find the values of a, x, n. So in a plus x whole to power of n, tr plus 1 is equals to ncr, first term power n minus r, second term power r. So first term is a, so a to the power of n minus r, second term is x, x to the power of r. So what he told, second term means t2, third t3, fourth t4. So t2 means compulsory we should write in the something plus 1. So 2 we can write as 1 plus 1. So 3 we can write as 2 plus 1. 4 we can write as 3 plus 1. So in this situation r value is 1. So our formula application nc1 a to the power of n minus 1 x to the power of 1. So in this r value is 2. So nc2 a to the power of n minus 2 r to the power of 2. In this r value is 3. So nc3 a to the power of n minus 3 x power 3. He given as 240, 720, 1080 respectively. Na? So which is equals to equation 1, 2, 3. So again here I am doing equation 2 by 1 and 3 by 2. Why we have to take this pattern means here observe same n 2 preceding 1. That's why we have to take equation 2 by 1. And here also 3 preceding 2 na compulsory 3 by 2 only we have to take. So nc2 a to the power of n minus 2 x square by nc1 a to the power of n minus 1 into x is equal to 720 by 240. 0, 0 cancel, 21 1s are 21, 3s are cancel RHS. And here you see the formula n same. So n as it is, denominator will come to numerator, numerator will be denominator. And x gets cancelled, numerator one more x is left over. And a power n cancel. But here a power minus 2, a power minus 1 is there. Minus 2 will come denominator, it will be plus 2. So minus 1 plus 2 will become simply a is equals to 3. So I am keeping x by a left side, sending to right side. So 2 3 is a 6, numerator will be denominator. Keep equation 4. Next, equation 3 by 2 I told na. So nc3 a power n minus 3 x power 3 nc2 a power n minus 2 x square is equals to 1080 by 720. So 0 0 cancel and cancellation will get here 3 by 2 answer. And here x cube x square cancel, only x left over. And here also a left over. Formula application n minus 2 by 3. So like this it left over, keeping x by a as it is. Denominator will goes to numerator, 3 3 is a 9. Numerator will come to down. Equation 5. Equation 4 and 5 LHS are equal. We are equating the RHS. So 6 by n minus 1, 9 by n 2 times of n minus 2. 3 2s are 3 3s are cancellation and cross multiplication 2 2s are 4 times and 3 into n minus 2. Multiplying 4 table, 4 into n, 4 2s are 8, 3 1s are 3. So sending n to this side, 8 to right side. So n value we are getting 5. Substitute 5 value, n value in the equation, either 4 or 5. In 4 it is better. So x by a is equals to 6 by n minus 1 na, n in the place 5 minus 1. So 6 by 4, 2 3s are 2 2s are cancel. So x is equals to what? 3a by 2. Keep equation number 6. Now substitute x value, n value in the equation 1. You can substitute 2 3 also, better off in the 1 better. So 5c1 a to the power of 5 minus 1 3a by 2 is equals to 240. Next, any c1 value is that number. nc1 value is n. So 5c1 value 5, a power 4, 3a by 2 is equals to 240. 3 table cancellation, then 5 table cancellation, then cross multiplication, 16 2s are 32. 32 we can write as 2 power 5. So powers are same, we can equate the bases. A is equals to 2. So we got n value, a value, but still x sign in na, so substitute in the x value. So x is equals to 3 into 2 by 2. So 2 to cancel, x value is 3. Therefore x a n. If the 36, 84, 126 are the 3 consecutive binomial coefficients in the expansion of 1 plus x whole to the power of n, then find n. It is like previous problem only, but here only asked x and n value, unknown numbers, only finding n. So in the expansion 1 plus x whole to the power of n, tr plus 1 is equals to ncr, first term power n minus r, second term power r. So 1 power anything 1, so only left over ncr x to the power of r. So Let us, the three consecutive coefficients are NCR minus 1 and NCR plus 1 as 36, 84, 126 is given. In the previous problem, terms given, now coefficients. That's why we should not take x power r, only coefficients we have to take. So equation 2 by 1, similarly equation 3 by 2, paper partition. So NCR by NCR minus 1 is equals to 84 by 36. So cancellations, will get 7 by 3 and n and same, denominator numerator, numerator denominator. So n minus r minus 1 by r. So n minus r minus into minus plus, cross multiplication. So 3n minus 3r plus 3 is equals to 7r. Take all the terms to the one side. So minus 3r, it will come left side minus only. Minus 3 minus 7 minus 10r. Keep equation number 4. The same thing, 3 by 2 equation. So n and same, denominator will be numerator, numerator will be denominator na. So n minus r by r plus 1. Here cancellation 3 by 2. Next cross multiplications, 2n 2r, 3r plus 3. Taking all the terms to left side. So 2n minus 2, it will come left side minus 5r and minus 3 is equals to 0. Solving equation 4 and 5. Here we have to find only n value na. I don't want r na. So try to equate the same numbers. Here 10r is there. Here 5r is there. So multiply equation 5 by 2 table. 2 5 is 10 na. That's why. So equation 4 as it is. Equation 5 will becomes 2 table. 2 2s are 4. 2 5 is 10. 2 3 is 6. Next, changing the sign. Plus will be minus. Minus will be plus. Minus will be plus. Cancellation. 3n minus 4n is minus n. 3 plus 6 is 9. Sending 9n to right side. Therefore, n value 9. Hence, find. If the coefficient of rth, r plus 1th and r plus 2 second terms in the expansion 1 plus x whole to the power of n r in AP, then show that n square minus 4r plus 1 into n plus 4r square minus 2 is equals to 0. Very important problem, confusion. In the expansion 1 plus x whole to the power of n, tr plus 1 is equals to ncr. First term means 1 power n minus r, second term power x power r. The coefficient of x power r is what? NCR. X power r is NCR. So, the coefficient of r plus 1th term is what? Here, TR minus NCR minus 1. Next one NCR. Next one NCR plus 1 will take sequence order. One is less, one is more. So, given as in AP na. So, NCR minus 1, NCR plus 1 in AP. AP means 2 into middle term is equals to sum of the first and last. So, 2 into NCR is equals to NCR minus 1 plus NCR plus 1. So, NCR will come to right side. Divide both the terms. So, you again see n and same. R minus 1 preceding R is not there. So, exactly formula not there. Here you see R plus 1 preceding number is R. So, it is exactly formula. But here not there na. So, we have to take numerator to denominator of the denominator. Then, it will becomes R preceding R minus 1 na. That's why we have taken to denominator. Here no need to take. So, here 1 by formula application n minus R minus 1. Numerator will be denominator by R. Here also n minus numerator and numerator will be denominator. So, denominator of denominator will goes to numerator. So, R by minus say multiply. So, n as it is minus r, minus into minus plus. So, n minus r and r plus 1. So, denominator LCM. So, this into this one denominator and crossly multiplication r into r plus 1 and n minus r into n minus r plus 1. Next, sending denominator to LHS and multiplying also direct step. So 2 into n into r nr, n into 1 n, minus r into r minus r square, minus r plus 1. And right side r into r square, r into 1 r and n into whole thing and minus r into whole thing. So like parts cancellation, r cancel here and here also r gets cancelled. Then multiply with 2 table and here like parts addition. We'll get 2nr, 2n minus 2r square plus 2 is equals to r square is 2r square and n square minus nr is minus 2nr plus n. Then take all the terms to right side. So as it is I written, then plus will becomes minus will becomes plus is equals to 0. Then like parts n square 2nr is minus 4nr and minus 2n plus n will be minus n and 4r square and minus 2 as it is equals to 0. So therefore n square, and here n came 2 times now, taking n common minus n common, so 4r plus 1 left over and remaining as it is, hence proved. Next question, if the coefficient of x power 9, x power 10, x power 11 terms in the expansion 1 plus x whole to power of n are in AP, then prove that n square minus 41n plus 398 is equals to 0. So in the expansion 1 plus x whole to power of n, tr plus 1 is equals to ncr 1 to the power of n minus r x to the power of r. So 1 power anything 1 only, so only ncr x to the power of r. So coefficient of x power 9 is what? X power r means ncr, x power 9 means nc9, 10 means nc10, 11 means nc11. So what he given in the question, nc9, nc10, nc11 are in the AP, arithmetic progression, means 2 into middle term is equals to first and last addition. So 2 into nc10 is equals to nc9 plus nc11. So nc10 will come to right side division. So nc9 by nc10. So 9 preceding 8 but not 10 na? So take to denominator, and here 11 preceding 10, so no need to change. So nc10 by nc9 means 10 preceding 9 means formula n as it is minus 9 by 10, and here also n minus 10, numerator will be by 11. So denominator of denominator again take to numerator, 10 by n minus 9 plus n minus 10 by 11, LCM. So n minus 9 into 11, 11 tens are, and n minus 10 into n minus 9. So cross multiplication 2 into, and just multiplying this also, 11n minus 99 is equals to here 110 n square minus 9n minus 10n minus into minus plus 90. Then multiply with 2 table and right side like term addition. So 22n minus 99 to the 198 is equals to n square minus 19n and 200. Take to right side. So plus will be minus, minus will be plus. Then like parts n square and 22 19 is 41 and 200 198 is 398. Hence proved. If P and Q are the sum of the odd terms and the sum of even terms respectively in the expansion of x plus a whole to the power of n, then prove that first bit p square minus q square is equals to x square minus a square whole to the power of n. Second bit 4pq is equals to x plus a whole to the power 2n minus x minus a whole to the power of 2n. So here given expansion x plus a whole to the power of n is equals to nc naught x power n. Next one nc1, first term will be decrease, second term will be increase. So first term is x power n minus 1 and second term is begin. nc2 x to the power of again decrease, increase. So n minus 2 a square and so on. So next x minus a whole to the power of n I am taking. Means same as it is, but in between minus means alternate sign will come. So plus, minus, and so on. So what he had given, P and Q are the sum of the odd and even respectively. Odd means this is first term, and this is third term. So these are odd terms, and this is second term. Next one is fourth term. These are even terms. So it is quite opposite. 0 looking, but it is odd term. So here P is equals to sum of odd terms means nc0 x power n. After 0 2 we have to take now nc2 x to the power of n minus 2 a square plus so on. Q means sum of the even terms. Even means reverse I told na. So nc1 x to the power of n minus 1 a. Next one what will come? 1 in the plus 3 you write plus so on. So simply we can write as this above equations as x plus a whole to power of n is equals to p plus q. Means these two addition only na. Next x minus a whole to power of n means these two subtraction only na. So p minus q. So here LHS is p square minus q square. Consider. So it is looking like a square minus b square formula. So a plus b into a minus b. So p plus q means x plus a whole to power of n. This means x minus a whole to power of n. So in the bracket terms looking like a plus b into a minus b na. So a square minus b square only single time power n. That is only our RHS in the first bit. Next coming to the second bit. In the second bit I am taking RHS. Why? Because critical thing is RHS. So x plus a whole to power of 2n minus x minus a whole to power of 2n. So power n whole square. It is also power n whole square. So it is looking like p plus q whole square as it is, and minus it is looking like p minus q whole to power of 2 as it is. So a plus b whole square elaboration minus as it is bracket open a minus b whole square elaboration. So next minus into whole thing, minus into minus plus. So p square q square cancel, 2pq plus 2pq 4pq. That is only our LHS, hence proved. Next, if the coefficient of x power 10 in the ax square plus 1 by bx whole to power of 11 is equal to the coefficient of x power minus 10 in the ax minus 1 by bx square whole to power of 11, then find the relation between the a and b where a, b are real numbers. So we need to find what is the relation between a, b. So here paper partition. So first part I am taking ax square plus 1 by bx whole to power of 11. In the second part, second expansion, ax minus 1 by bx square whole to power of 11. So in this general term, tr plus 1 is equals to ncr. First term is ax square whole to power of n minus r. Second term is 1 by bx to the power of r. So here 11cr, a to the power of n minus r, and n in the place I am writing 11. So ax square power 11 minus r, 1 by bx to the power of r. So 11cr, so a to the power of 11 minus r, x to the power of 2 into na. So 2 into 11, 22 minus 2r into 1 by b power r means denominator, x to the power of r also denominator. So constant I am writing first, then variable. Variables are what? X to the power of 22 minus 2r and x to the power of r. Bases are same. Power should be subtracted in the division. So x to the power of 22 minus 2r, and this is minus r. So x to the power of 22 minus 3r remaining as it is. Next, here what he told, in this another expansion, ax minus 1 by bx square whole to power of 11, tr plus 1 is equals to ncr. First term is ax power n minus r. Second term along with minus we should take minus 1 by bx square whole to power of r. So n in the place 11. So 11cr, ax to the power of 11 minus r minus 1 by bx square whole to the power of r. So 11cr, a to the power of 11 minus r, and x to the power of also 11 minus r, and here minus 1 to the power of r compulsory, and denominator b to the power of denominator x square into r na. So x power 2r. So again constants, only variables later. So variables are what? X to the power of 11 minus r, x to the power of 2r. So bases are same, power should be subtracted. So 11 minus r minus 2r. Minus r minus 2r is minus 3r. So in the paper partition, what he told? To get the coefficient of first term x power 10, we equate the power to 10. So in the first equation, what is the, in the first part, x to the power of 22 minus r 3r na. So 22 minus 3r is equals to 10 we should take. So 3r right side, 10 to left side. So 22 minus 10 is 12. So 3r. Therefore r value is equal to 4. In the second paper partition, we get the coefficient of x power minus 10. So we equate the power to minus 10. What is x power? 11 minus 3r we got. That is equals to minus 10. So take sen. So 11 plus 10 is 21 is equals to 3r. Therefore r value is how much? 7. Next, we have then given coefficients are equal now. So substitute r value in the above and r value in the above partition 7. So it will be what? 11c4 a to the power of n minus r. N minus r means 11 minus 4 is 7. Next b to the power of r means 4. In the second part also what we got? 11cr means 11c7. A to the power of 11 minus r means 11 minus 7 is 4. Minus 1 to the power of r means minus 1 to the power of 7 by b to the power of r. R means 7 na. Then what he told, both are equal he given na. So equating these two, 11c4 is equals to this one also 11c7. So here you see a power 7 I am writing a power 4 a cube by b power 4 as it is. And here a power 4 I am writing as it is. Minus 1 to the power of odd number will give you minus only. Even means plus, but here odd na minus. And b power 7 also I am writing as b power 4 b cube. So b power 4 cancel, a power 4 cancel, and 11c7, 11c4 both are equal values. So those also cancel. So denominator b cube left over, cross multiplication, a cube b cube is equal to minus 1, ab whole cube is equal to minus 1 cube also we can write as 1. So cube cube cancel. Hence the AB relation is AB into 1 is equals AB into is equal to minus 1. If n is a positive integer, then prove that summation r is equal to 1 to n r cube ncr by ncr minus 1 whole square is equals to n into n plus 1 whole square n plus 2 by 12. So here consider the LHS. Summation r is equals to 1 to n r cube into ncr by ncr minus 1 whole square. So summation as it is. Here formula application ma n and same, r preceding r minus 1 na. So denominator numerator will come, numerator. So n minus r minus 1 by r. So minus r, minus into minus plus, and numerator whole square separate and denominator r square separate. R square cancel, one more r left over. And here I am taking n along with 1 and minus r separate. So applying the a minus b whole square formula, a square plus b square minus 2ab. Next multiply with r table, summation r into whole thing. So summation r into n plus 1 whole square, r into r cube, r into r square. So n into 2 into n plus 1. Here summation only for r letter. So remaining are constant. So n plus 1 is constant in front, r is inside. Only r cube inside. Here 2 is constant, n plus 1 is constant. So r square is inside. So summation r is equal to 1 to n. R means what? Sum of the natural numbers only na. So simply we can write summation n cube, summation n square remaining as it is. Next n plus 1 whole square. Sum of the natural numbers formula n into n plus 1 by 2. Sum of the cubes of the natural numbers is formula n square n plus 1 whole square by 4. And 2 as it is, n plus 1 as it is. Sum of the squares of the natural number formula n into n plus 1, 2n plus 1 by 6. So in this what is common terms? N plus 1 whole square, n plus 1 whole square, n plus 1 into here n plus 1 is there. So n plus 1 whole square common. And one more thing, one n and here also n. So taking common of n plus 1 whole square, and denominator also 2 table. So what left over? Here n plus 1 left over, constant nothing. Here one more n left over, 2 table left over. And here 2n plus 1 left over, and here numerator 2 is left over, denominator 3 is left over. So LCM of denominator 2 3s are 6. So 6 into whole we have to 2, and here 2 table covered, only 3 table. Here 3 table is covered, only 2 table. So 2 2s are 4. So multiply with 6 table, here a 4 table. So 6n plus 6, 3n minus 8n minus 4. So plus 6n plus 3n is 9n, 9n minus 8n is 1n, and 6 minus 4 is 2, and denominator 6, and in front as it is we continue now. So 2 6 are 12, and these n into n plus 1 whole square as it is. Here left over n plus 2 na, that is only our RHS.